In supply chain management, the goal is to evolve logistics systems beyond simple task execution to achieving genuine agency. Automation in the supply chain typically means systems executing fixed rules or scheduled routes. Agency, however, means creating an intelligent system that perceives, reasons, and acts autonomously toward defined business goals, such as maximizing delivery efficiency or minimizing inventory holding costs. This shift enables the system to answer the critical operational question: what should be done next and why? Instead of merely triggering a standard replenishment order. An intelligent system with agency perceives multiple related factors, such as weather delays, port congestion, a competitor's recent pricing action, reasons about the combined impact, and acts proactively to maintain the flow of goods. As an example, imagine an automated system processes an order and sends it to the nearest warehouse, following a fixed rule. A system with agency perceives a sudden major traffic incident, impacting the nearest warehouse's main exit route. This is perception. Reasons that shipping from a further warehouse will result in a faster total delivery time. This is reasoning, and autonomously reroutes the shipment to the alternative depot. This is action. Once the system has agency, it must be capable of processing vast, fluctuating data quickly enough to maintain operational stability. This is machine speed decision-making. Given the volatile nature of global logistics, resulting from fuel prices, geopolitical shifts, sudden consumer demand spikes, the system must operate at the speed of business. Machine speed means the intelligent system is constantly analyzing, correlating, and recommending actions in near real time. This rapid processing ensures the system can immediately determine what should be done next. And when facing dynamic challenges, such as unexpected spikes in the cost of air freight or a critical supplier going offline, consider a system that detects a sudden massive increase in social media chatter, indicating a viral product demand surge. Traditional systems would wait hours for sales data aggregation. The machine speed intelligent system correlates the chatter with current inventory levels, and automatically places provisional orders for raw materials, and reserves transport slots within minutes, thus maximizing opportunity while minimizing the risk of a stock out. The speed of decision-making must be coupled with unbiased accuracy. This requires objective, adaptive intelligence. In most operations, humans often rely on established relationships or historical practices. For example, using the same carrier for decades. Objective intelligence requires the system to evaluate every scenario through an objective, data-backed lens. A key benefit is the ability to reduce the sunk cost bias. The system does not care if the company just spent 5 years building a relationship with a specific packaging vendor. If the data objectively shows a new vendor offers superior metrics across cost, reliability and lead time, the system will recommend the switch, focused purely on optimizing the current business goals. Picture this scenario. A company has invested heavily in proprietary software for managing a specific fleet of internal delivery vehicles. A sunk cost. The objective intelligence system evaluates the total cost of ownership, maintenance records, and fuel efficiency data against external commercial trucking alternatives. If the data suggests that switching to outsourced logistics, a full departure from the internal fleet investment, is the optimal path forward to reduce overall costs, the system recommends this radical change, determining what should be done next and why, unencumbered by emotional attachment to the prior investment. When systems operate autonomously, at machine speed, and objectively recommend challenging changes, like switching major suppliers, human trust is essential. This requires an emphasis on trust and explainability through robust governance. Complex, high-value decisions in logistics must be transparent. Trust is maintained by including human-in-the-loop controls. This ensures that any recommendation made by the system is traceable, transparent, and subject to human review before execution. This governance is crucial for large financial commitments, safety protocols, and regulatory compliance within the supply chain. For example, the objective intelligence system recommends chartering a specific type of container vessel for a major transoceanic route, because it offers the highest projected ROI based on predictive demurrage and fuel cost models. Because this involves millions in committed funds and safety inspections. The system generates a detailed, transparent report explaining the data sources, the correlations it made, and the specific algorithms used. This allows a logistics director to provide final sign-off, ensuring the complex decision is fully understood, verifiable, and safe before the transaction is executed.